I am dealing with the topic is activation function. Activation function is nothing but it decided neuron should be activated or not. Activation function introduces a non-linearity to the neural network. By the adding of non-linearity to the neural network, the model makes complex decisions and predictions. The choice of activation functions are suitable for different types of tasks. There are types of activation functions: sigmoid activation function, tanh, ReLU, like-ReLU, softmax. Here sigmoid activation function, it is used for the models where we have to predict the output. It is exist only the range of 0 and 1. Here I am taking sigma of x equals to 1 by 1 plus e power minus 6. Here I am derivating this function. Derivative of sigmoid x is equals to d by dx of 1 by 1 plus e power minus 6. By the solving of this, I am getting as it is the sigma of x is equals to 1 by 1 plus e power minus 6 into e power minus 6 plus 1 minus 1 by 1 plus e power minus 6. Here I am considering as is this function is equal to sigma of x and 1 here 1 minus 1 plus e power minus 6. Here getting derivative of sigma x to sigma x of 1 minus sigma x. Half of sigmoid activation function. Here I am substituting the x values. Here x equal to 0. I am substituting in the place of e power minus 6. 1 by 1 plus e power minus 0 is equals I got 0.5. Like that I am substituting the value x is equals to 1, x is equals to minus 1, x equals to 2, x equals to minus 2, x equals to 3, x equals to minus 3. I got these values. These values substituting in the graph. I am taking here x-axis, here y-axis. By the substituting of these values, I got the graph like this shape. This is the shape of sigmoid activation function. Tanh activation function. These values can be lies between minus 1 to plus 1. Here tan h of x is equal to e power x minus e power minus 6 by e power x plus e power minus 6. Here I am doing this derivation. The derivative of tan h of x is equals to derivative of e power x minus e power minus 6 by e power x plus e power minus 6. By the doing of this derivation, I got tan h of x is equals to 1 minus tan h of x whole square. This is the derivation of tan hx. Here the graph of tan h. I am substituting the value of x. Here tan h of minus 3 is when we substitute minus 3 in the place of x, I got the value minus 0.99. When like that, I am substituting the value minus 2, minus 1, 0, 1, 2, 3. By the substituting of these values, I got these values. Here I am plotting the graph. Here taking x-axis and y-axis. By the substituting of these values, I got the graph like that shape. This is the ReLU activation function. This values lies between the range of 0 to infinity. Here the max of 0, x. In this ReLU function, we are taking the negative values as 0 and positive values as it is. Here g of x is equals to x if x is greater than 0. 0 if x is less than 0. Here I am doing the derivation of g of x. G derivation of x is equals to derivation of, when we are doing the derivative d by dx of x, I got 1 and d by dx of 0, I got 0. Here the graph of ReLU function f of x is equals to max of 0, infinity. When we substituting the value of x, here I am taking x value 1, I got this is the positive value, so I got as it is 1. When we taking the negative value like x is equals to minus 1, I got 0 because all negative values considered as 0. This is the graph of ReLU activation function. Here all negative values considered as 0, positive values taking as it is. This is the like-ReLU activation function. The range of like-ReLU is minus infinity to plus infinity. This leaky ReLU helps to increase the value of ReLU function. Usually the value A is 0.01. Here the max of 0.01 x comma x. Here considering f of x is equals to 0.01 x if x is less than the 0, x if x is greater than the 0. Here I am doing the derivation of f of x, dy dx of 0.01 x if x is greater than 0. Here I got here dy dx of x is 0.01. When we doing of dy dx of x, I got value 1. Here the graph of leaky ReLU activation function. F of x is equal to 0.01 x for x is less than 0, x for x is greater than equal to 0. Here I am taking the x values 0.1, 0.2, 0.3, 0, minus 0.1, minus 0.2, minus 0.3. When we doing a max of 0.01 x comma 0.1, when we taking the x value 0.1, I got 0.1. When we taking x is equal to 0.2, I got 0.2. When we taking of x is equal to minus 0.1, I got minus 0.001. By this taking of this value, I plot the graph. Here the graph of leaky ReLU activation function. This is the softmax activation function. This activation function lies between the values 0 to 1. It is used for multi-class classification. I am considering this f of xi is equals to e power xi by summation of e power xi. By the doing of f dash of x is equals to derivation of e power x by summation e power xi. By doing of this derivation, I got f dash of x is equals to f of x into 1 minus f of x. The derivation of softmax. This is the graph of softmax activation function. This graph also as it is like sigmoid activation function. Sigmoid activation function and softmax activation graph shows the same shape. These are the activation functions. Based on that model, we use the different types of activation function. Sigmoid is used for binary class, softmax is used for multi-class classification.